Hello friends, in this video we will see why C programming is a preferred language of choice to write an operating system. So one of the main reason is pointers, and in this video we will see just one point which will definitely tell you that C is a preferred language for writing an operating system or any program which requires less memory. We'll see. So we'll see in this video how to send an array to a function. So we will use pointers for sending an array to a function. So we have defined a function here which has a return type int and two parameters, input parameters. Those are star a and n, both of type int. The first one is the pointer. So when we call this function, we have to send an address to this function. So that address will be obtained by a. So a will contain the address received in the function call, and star a will point to that address. Assume if you send address 2000, so a will contain 2000 and star a will point to the location 2000 and will get the value. Star a is nothing but the value at 2000. So that's an example what I gave you. And we have one more variable n which we will use to receive the size of the array. So after that we have declared a variable I and sum of type int. We initialize sum to 0. And we are using a for loop. Here I is used only for loop iteration. So I want to execute this loop n number of times. If I say the size of the array is 10, I want the loop should be executed 10 times. And we are not using I for any index values here, as we use it in a normal array. So here sum is equal to 0, sum plus ai, you know this logic, will add the value at the first location. So initially the star a will be pointing to the first location of the array, that is first memory location of the array, a of 0. So it will be pointing to a of 0. That value will be put into sum and will be added and given to sum. So it's saved in again sum. After that, when I say a plus plus, the a will not increment by 1. So this will increment pointer to point the next memory location. If the pointer is of type integer, it will point to the next memory location, that is after two numbers. That for example, if 3000, currently star a will be pointing to 3000. If we increment a plus plus, it will not point to 3001, it will point to 3002 because integer is of 2 bytes. I'm talking about a 16-bit compiler. In 16-bit compiler, integer is 2 bytes. So when we say a plus plus, the address is initially it's pointing to 3000, it will point to 3002. Next time if we increment, it will point to 3004 and next 3006. So if it's a float, in the 16-bit compiler, float size is 4. So if the first location pointed by star a is 3000, the next, when we increment a plus plus, it will point to 3004, and next we increment again, it will point to 3008. We'll see that in a moment. So after the calculation of sum, after the loop completes, we'll calculate sum and return the sum to the calling function. So that will be returned to the sum of this calling function. This may be a main function. So main function also contains a variable called sum. Sum is equal to sum of, we'll calling the function. We are sending address. You can see I'm just typing here a. Whenever we put only the name of the array, it's nothing but ampersand a of 0. That is the address of the first index, the first memory location of the array. So we can either say this way, ampersand a of 0, or just a in case of arrays. Only in case of arrays, when we say the name, it is nothing but the address of the first location. So if you are not comfortable with this, you can either use this or this one, depending upon your choice. I always prefer to use a, just the name of the array. So what is pointer incrementing? We'll assume we have an array of size 4, that is a, and we have declared a pointer variable a pointer. So we are assigning the address of the first location, that is a of 0, ampersand a of 0. A of 0 is the location. The address is given by ampersand a of 0, that will be assigned to a pointer. You can do it either this way or this way. You can just say a and the address of first value, that is 3674. 3674 will be given to a pointer, and star a pointer is now pointing to this locations. So whenever we access star a pointer, we get the value at this location. So you can see here, you have to observe this. Whenever an integer is declared, it occupies 2 bytes of memory. That's the 2 memory locations here. 1 byte, 2 bytes. So 2 byte of memory location is allocated, and the next memory location address is 76. You can see 74, 76. So whenever we do an increment, so when we say a pointer plus plus, so it increments to 3676 from 3674. It does not increment to 3675. It will not increment by 1, which happens with a normal variable. When we increment a normal variable, it always increments from 74 to 75. But a pointer variable, when you increment, depending upon the, if it's an integer, it will point to the next memory location, that is 2 after 2 plus 2. If it's a float, it increments by 4. If it's a character, it increments by 1, because characters are 1 byte in a 16-bit compiler. So this way, if I say a plus plus 1 time, it will be pointed to here. If I say 2 times, from here 3674 to 367678, so 2 location will be incremented, and it will contain 3678. So it will point to the next and the next memory location. So this way, whenever we increment a pointer, it will not increment by 1, it will actually increment to the next memory location depending on the type of the variable. So we will see what is returning an array from the function. So how can we return an array from the function? We have declared a function, we have defined a function array in. So this is a function which will take the values from the user and will give and will send it to the main function. So we can call it from a main function, we can call it from any function. So we are declaring a variable I of type int. So this will also receive an address of the first memory location. We will send address of the first memory location of the array when we do a function call, and we will send the size of the array. So I will say enter the values of array. So user enters. So here again we are using I for only iterating the loop n number of times and not for any index. So here you can see %d, we are taking an integer, and I'm not saying ampersand a of 0. So ampersand a of 0, you can either say ampersand, but here it's not suitable to say ampersand a of 0. It is best you can use the address. So a will give you the address of the first location. Next time when you increment, it will point to the next memory location. So this way you can use a and it will take the value to that address. So scanf, we always use ampersand for the address. In case of array, you don't have to give ampersand here. If when you say a, only the array name or the pointer name, you can say pointer. This is the pointer. So this actually contains an address. So a will contain actually an address. We send the address here. So a contains an address. So for that address, a scanf will happen and the data will be sent. So now we increment this, the pointer will increment to the next memory location. So it takes 10 type. If we send size of array as 10, so 10 values will be taken and it will be saved in memory location as which is same as the memory location of the main function. So this is, if this is an array of a of 10, we are sending the address of the first location. You can see here I have written a, or you can also say ampersand a of 0. So we are sending the address of first location. So in this function, so it is going one by one on the next location, accessing the same memory location of main function's a variable, that is the array variable. The same location is accessed by this function and also the main function. So this way we can take an input from the function and return more than one value from the function to the main function or any other function. So we'll see some programs in this video. So before going to programs, I'll let you know. So here we have only one copy of array. You can see in the first program what we did here. We are sending an array to the function. We are not making a copy of the same function. We are just sending the address of the same location. So assume in huge programs, in huge graphical editing programs, we have to do some function. For example, we have to do brightness or any a large manipulation of a picture. So we have to send that picture to a function. So we don't have to make a copy of it. We have to just give the address of the picture to the function. So then that function will access the same memory location. So you can use memory, that is the RAM, in your computer in an effective way if you use pointers. You don't have to make multiple copies. And again, speed of execution of the program is also fast because we are not taking time to copy the values into the local variables. So the speed of execution is fast. So C program uses pointers. So we use pointers in C program and write operating systems. We write games. So games also require speed. So this way, C is a very powerful language. Even after decades, C still rules when it comes to low level programming. For example, hardware programming, C is the best language for speed and memory consumption. So pointers we use mainly because we want to save memory, we want to increase the speed of the program. So we'll see some programs in this video, the simple programs which will help you to know how the same program which you saw now, we will execute those programs and see. By this you can understand how an array can be sent to a function and how we can retrieve the array from the function. So we have a function here, the same function arrayin. This function will provide input values to the main function. It will take the input from the user and it will give the main function the values. So we already seen this logic. So a for loop is just to iterate n number of times, and here a is nothing but the address of the first memory locations. Next time when we increment, it will point to the next memory location. So array output, we can also send an array and print the array. So we will see one by one how it exactly happens. I'll compile this program, Alt F9 and do Control F9. I'll give the size of array as 5 and press enter. Enter the values of array 1, 2, 3, 4. Okay, I need to give space 1 space 2 space 3 space 4 space 5. You can see the values of the array are, so it's giving square of the array. So we are doing a function called square of the array. So how we are doing it actually, so you can see this function is returning more than one value. You can see this function is taking an input from the user. So we are first sending the main function. You can see I'm calling first arrayin. Arrayin, we are sending the address of the array. So first we declared array of size 50 and we just want to use, for example, if the user enters 5, we only use 5 values in the 5 indexes, the 5 memory location in the 50 location. So we will say enter the size of the array. The user will enter the size. So that will be the size. And now we are sending the address of the first memory location, that is a of 0. I'm sending a of 0 and comma n. N is the size of the array. So this arrayin function is called. So once the arrayin function is called, so here this receives the address and star a will point to the first address. So we are taking value one by one. So when we increment, it increments to the next memory location and it will take the value for a of 1, and then next the loop executes again. So it increments to next memory location. So it will point to a of 2 and will take value for a of 2. Again increments to a of 3 and then again the loop executes and value will be taken for a of 3. So similarly it will take until a of 9, because if we are using 10 as n, it will take until a of 9, but it is accessed using the address, not by the index values. So we send the first address. So this function will take care to iterate to the next memory locations. Arrays always saved in consecutive memory locations. So arrays, all the values a of 0, a of 1 will be in the next memory locations. So we can iterate using a for loop and access all the location of the same memory which is used by main function. The same array can be used from this function. So again, next we are calling the square function. So this square function will square all the values in the array. So it will go to the same memory location. You can see this is the function. We are sending the address to A. So every place it is accessing the value here. It's multiplying by itself and saving the value in the same location, and again it increments the next location, and then again it takes the value from this location and multiply by itself and again stores the value in that location and goes to next memory location. It's like if we have 10 boxes, we go to the first box, we take a number from it, we'll square that number and put that in the same box. We'll go to the next box, we'll take one more, there will be one more number in the second box. We'll take the box number and square the number and put it back in the same box. So that box is accessible by both main function and this square function, because we have sent the address from the main function to this pointer variable. So after this we use a array out to output the value. So we are sending the address of the first box or the first location. We'll consider it as a box. So we're sending the address of the first box. So this array out will receive the address of the first box. It will go to that box and take the value and output the value. So again it goes to the next box, that is the next memory location, takes the value, it outputs the value. So this function will square all the values in the boxes, and this function will output all the values in the each boxes. So we are giving the same address for all the three functions. All the three functions are accessing the same A of 0 to A of 9 of the main function. So you have to consider, so this is a powerful tool. We can use only one memory location instead of copying the values to the functions every time. Call by address is one of the powerful tools. So we'll see how to do sum of all the values in an array using a function. You can see, and using the same array input function to take input, we are sending address here and we are incrementing to the every location and scanning the value to, we are giving input to each location. So since we are using the same address, we'll consider it as 10 boxes. So we are giving the address of the same box which we have declared here. We have declared 50 boxes. So we will use the 10 boxes using this n number. We'll enter 10. So it will use only first 10 boxes. So first box address will be sent to the array in function. So it will access the same box using that address. So it will input the values using this for loop. And again, after the array in function is executed, so it comes back to the main function. It prints the sum. See here, we are returning in the same printf call statement. So you should be careful. If you write a function here, it will return the value. Instead, you can do something like this. You can say sum is equal to sum of a comma n. You can call like this. And print the sum variable. So you have to declare the sum. Okay. Sum is a variable now. So you can either use this variable or directly without declaring this variable, you can call the entire function in this place. So you can do either way, no problem. We'll do Alt F9 to okay, there's an error in the program. We'll see what exactly. Call to a non-function. Okay. What exactly the value is? Okay, we'll give a different name because there can be a conflict. Okay, now we can see there's no conflict. So sum1 is assigned value but never used. Okay, we have not print. So now we do Alt F9. Okay. So there, if you give same names, so there will be a conflict and you will not be able to. So I've used sum1 and sum1 as a variable and sum as a function name. So I can call this way, and I'll do Alt F9 and Control F9 to run the program. So size of array, enter 4. So enter the values. I'll say 2 space 3 space 4 space 5. You can see sum of the array elements is 14. So it will give you 14 as value. You can either call it this way, or you can also say, as we previously saw, a comma n, and I'll delete this. Control F9. So I'll say size of array is 6. I'll enter the array 2. So you can see we get the output this way. So we can use either this way or that way. So that is your choice. Friends, in this video we saw that pointers can be used to send an array to a function or receive an array from the function. So in the upcoming videos we'll see more. Thank you for watching this video.